Hey there. Today we're looking at solving quadratic equations, and this segment focuses on one specific technique, which is solving by using the all-powerful quadratic formula. Now, really becoming adept at using the quadratic formula is very good for you. It is the most useful technique because it can solve any quadratic equation. We've talked so far about solving quadratics using factoring, and we've also talked about using the technique of taking square roots. And not all quadratics are factorable. Some of them are prime. Not all of them set themselves up for solving using the square root property, but all quadratics are solvable using the quadratic formula. So that makes this a really useful tool. So the very first thing that you want to keep in mind while you are solving using the quadratic formula is you must have your equation in standard form. Standard form means, you are, you've got your terms in descending degree order from left to right, and everything's on one side of the equation and it's all equal to 0. Okay, so that's the first thing you need to keep in mind. And then you're going to utilize the all-powerful, all-knowing quadratic formula, which is this: x is equal to negative b plus or minus the square root of b squared minus 4ac. That's all under the radical. And all of that is over the expression 2a. So once you've got your equation in standard form, you've got something like this: ax squared plus bx plus c is equal to 0. And it really comes down to just taking the appropriate numbers, which are the coefficients and the constant, and subbing them into your formula and then simplifying. So let's take a look at a couple of examples. Let's start with, let's see, can we do that now? Let's start with x squared equals 2x plus 4. Notice we are not in standard form, so we are going to first move the furniture around. We are going to move everything to one side of the equation. And since our x squared is on the left, let's shift everything over to the left. So x squared minus 2x minus 4 is equal to 0. Okay, so now I am in the correct form, and I want to identify what are a, b, and c. Okay, so a we know is the coefficient x squared, which is 1. B is the coefficient of the x, which is negative 2. And c is our constant term, which is negative 4. Now we're going to take these values and substitute them into the quadratic formula and go ahead and solve from there. So our quadratic formula is x is equal to negative b. So negative 2. And we'll simplify that in the next step. Plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a times c. So 4 times 1 times negative 4. And we're off the page. Let's move that. So we're not off the page. Okay. All right, and all of this is over 2 times 1. So now it comes down to, let's clean this up and simplify it a little bit. So I always like to start with what is under the radical, because there's a ton of stuff under the radical that if I can simplify that, my whole equation looks so much nicer. So let's look. If I've got negative 2 squared, that's the same as 4 minus, okay, and now I'm looking at 4 times 1 times negative 4, and then that would be negative 16. So 4 minus negative 16, that minus minus becomes a plus, and we have 20 as our radicand. So when I clean things up here, I've got negative negative 2, which is positive 2, plus or minus the square root of 20, and that's all over 2 times 1, which is 2. Okay, so we're not quite finished. We need to continue simplifying. Many students can get this far and then they're not really sure what to do after this. So let's take this and simplify this radical. We know that the square root of 20 is the same as the square root of, or I'm sorry, 2 square root of 5. And that's all over 2. Okay. And then we notice that we have 1, 2, 3 kind of terms in our fraction. All 3 of them have a common factor of 2. So we can divide out the 2 on everything. So that would end up being 2 divided by 2 here is 1. Plus or minus 2 divided by 2 here is 1 radical 5, otherwise known as just radical 5. And 2 divided by 2 here is 1. So our denominator is 1. But we don't actually need to write a denominator of 1. So at this point we have our solution, and we're going to just simplify our answer. So our solution set here is 1 plus radical 5 and 1 minus radical 5. And that will take care of that problem. So let's look at another problem. Perhaps one